Hi, today I want to discuss about polymerization mechanism. In that, one of the important mechanism is free radical mechanism. Polymers can undergo ionic mechanism as well as free radical mechanism. One is ionic. In this ionic mechanism, we have two types. One is cationic mechanism and second one is anionic mechanism. The next one is free radical mechanism. So according to textbook, we will discuss the first one is free radical mechanism. Variety of alkenes or dienes and their derivatives are polymerized in presence of a free radical generating initiator, that is called catalyst. Like some of the compounds they given here, benzoyl peroxide. Benzoyl peroxide formula is C6H5CO 2 times this is benzoyl and taken O2. This is benzoyl peroxide. Acetyl peroxide is CH3CO taken 2 and O2. Tertiary butyl peroxide is like this is called tertiary butyl. This is a peroxide bond. This is also called tertiary butyl peroxide. Oxygen oxygen single bond present mean that is called peroxide. For example, the polymerization of ethene to polyethylene consists of heating or exposing to light a mixture of ethene with small amount of benzoyl peroxide initiator. So how to understand this mechanism, that is given in the form of sentence, that is chain initiation step. It means starting for mechanism. The process start with the addition of phenyl free radical. How this form, you just read that this sentence. I will give the explanation with equation. This is propagation step, then next termination step. So these all sentence form now I will explain with the equation. Now we are taking one example is benzoyl peroxide. What is that? Benzoyl peroxide. C6H5C double bond O C double bond O C6H5. Oxygen oxygen single bond. This bond is weakened because of this lone pair. It undergo homolysis cleavage and break like 2 moles C6H5 C double bond O and here lone pair and this is a unpaired electron free radical. Next step, this C6H5 C double bond O lone pair and unpaired electron. Again this bond will be break if this is a covalent bond. Then this also undergo homolytic cleavage. Then we will get here C6H5 free radical. Here 2 moles are there, therefore here also 2 mole, then here also 2 mole. Here unpaired electron and here unpaired electron both combine to form, that is carbon dioxide, double bond C double bond O. This is also known as a carbon dioxide. Now this is a free radical initiator. This is called phenyl free radical. Now this phenyl free radical added to ethene C6H5 added to CH2 double bond CH2. This is called ethene. Then now this will form C6H5 CH2 CH2, a larger free radical, smaller free radical thrown to larger free radical. This is called initiation step. This is called initiation step. The second one is called propagation step. In this propagation step, we have another ethene molecule C6H5CH2CH2. How here this free radical forming? Here also this pi bond homolytic cleavage undergo. Then this free radical and this free radical both combine to form bond. These are combined to form bond. Then this free radical remain. Therefore here unpaired electron. So now here we have this unpaired electron reacted with the CH2 double bond CH2. Then this pi bond undergo homolytic cleavage and this will be given as C6H5CH2CH2, already 2 carbon, and next CH2CH2 total 4 carbon and free radical. This will be formed. Now this will undergo like number of time, then we will get C6H5CH2CH2 and CH2CH2 and here dot. Now we can write this is taken N, like this number of molecule added to this free radical then form a larger free radical. Now in termination step, in the chain termination step, this is called termination step. In termination step, these long chain free radicals now react like this. C6H5 CH2 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 and another CH2 and dot. Then we have this is N number. Another one also reacts C6H5 CH2 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 free radical. Now this is taken N. These are combined to form a big chain, that is C6 C6H5 CH2 CH2 another CH2 CH2. This is the first molecule. Another one CH2 CH2 CH2. Now I am writing down bond. This is CH2 total 1 2 3 4. From here onwards 1 2 3 4 and one total number of carbon is 4 plus 4 total 8. So 1 2 3 4 5 6 7 8 and here C6H5. Now we have the taken N here and next one we have taken N here. Then this is chain terminated and it means reaction stop here. Next, so many molecules undergo this free radical mechanism. Now some important addition polymer detailed study, that is preparation of some important addition polymer and their properties also. In that first one is polyethylene, that is called polyethylene simply. There are two types of polyethylene as given below. One is low density polyethylene, that is simply known as LDP. LDP means low density polyethylene. Low density polyethylene is generally represented as like this. These are the linear polymers, and these are having some branches. Due to this some branches, then volume will be increased and density will be decreased. So we know that density formula, that is M by V, volume increases, density decreases. That's why this is called low density polyethylene is highly branched. This is generally highly branched. When this is highly branched, packing will be loose, therefore density will be less. So how to prepare this one mean? So I am writing here equation, that is n number of ethene molecule, this is called ethene, then this will be undergo polymerization, then gives CH2 single bond CH2. Pi bond lost, that's why left side one bond, right side one bond, and taken N. This is now look like linear, but actually this representation is highly branched like this. So this is called low density polyethylene. This will be catalyzed in presence of oxygen or peroxide at nearly 350 Kelvin to 570 Kelvin temperature and 1000 to 2000 atmospheric pressure maintained. Okay. And next one, this is generally free radical mechanism. Free radical mechanism. Now, this is LDP. What is the its property and uses? Now, low density polyethylene. Low density polyethylene is chemically inert. Chemically inert means do not react with other substance. It is tough. It not easily break, but flexible. Now you take the water bottles. It means Kinley water bottle, Aquafina water bottle. If you squeeze that, it is squeezable. It means flexible. And some water pipes also they are flexible. Some water pipes are like stick type, they are not flexible. Some are for the car washing purpose used pipes are flexible like this. So tough but flexible. A poor conductor of electricity. If you pass the electricity, do not allow the current through it. Hence, it is used in the insulation of electricity carrying wires and manufacture of squeeze bottle, toys and flexible pipes. Some toys also flexible and squeeze bottle, flexible pipes. These are the uses. So how to differentiate the LDP and HDP? After HDP I will explain you that. Next, HDP explanation how to prepare this is same equation, n number of ethene molecule, this is ethene, then on polymerization this will give CH2 single bond CH2, then both sides single bond taken N, this is linear polymer without branching, therefore highly close packed. When it is highly close packed, density will be increases. Then this is called HDP, high density polyethylene. You may observe that on some pipes this LDP, HDP word also may be mentioned. So here this is catalyzed with the R3Al plus titanium tetrachloride. This is called Ziegler Natta catalyst. In this one, active species is titanium plus 4, important for competitive exam. And this is catalyzed at 333 to 343 Kelvin temperature and 6 to 7 bar or atmosphere pressure. So this is about the preparation of HDPE, high density polyethylene, and its mechanical property and uses are: 1. High density polyethylene thus produces consists of linear molecule. There is no branch. High has a high density due to close packing. Then next one, It is also chemically inert, more tough and hard. But you observe in the low density polyethylene that is tough but flexible, but in high density polyethylene tough and hard. So this is the main difference of the HDPE and LDPE. It is used for manufacture of buckets, dustbin, bottles and pipes, etc. These all are tough and hard, but these HDP not used for flexible purpose. That is the main difference you have to remember. Next one, polytetrafluoroethene. This can be prepared from n number of CF2 double bond CF2. This is called tetrafluoroethene. This can be on polymerization converted into CF2 single bond CF2 single bond and taken N. This is called Teflon. This is fully fluorinated polymer. This can be catalyzed in presence of persulfate or some free radicals or some free radicals at high temperature and pressure, high pressure. Now, its mechanical property and its uses. It is chemically inert and resistant to attack by corrosive reagent. So generally these polymers LDP, HDP and this Teflon are chemically inert, do not react with any other substance. Now resistance to attack by corrosive reagent. It means not easily corroded with any other reagent. Next one, it is used in making oil seals and gaskets. You know that in pressure cookers having one rubber type compound, that is gasket, and to make the oil seal purpose also used. And you may be heard also nowadays for car coating, that is Teflon coating, for not easily rusting purpose used, and also used for non-stick surface coated utensils. Non-stick cookwares also, you know, in our household some utensils. Next one, Teflon coating undergo decomposition at temperature above 300 degree. Anyway, at high temperature anyone some compound will be decompose. That's why these are not that much preferable for cooking purpose, but also nowadays you are using for non-stick purpose, but try to reduce the non-stick cookwares. Next, another important polymer is polyacrylonitrile. This can be prepared by n number of CH2 double bond CHCN. This is called acrylonitrile. This is a common name. N number. Then it is undergo polymerization and convert into CH2 single bond. How to write the polymer structure? Remove the pi bond and left right you have to put the single bond and taken N. This is called PAN. PAN means polyacrylonitrile. This can be polymerized in presence of peroxide catalyst. Okay. Now, its uses and its properties. 1. Polyacrylonitrile is used as a substitute for wool in making commercial fibers as Orlon or acrylon. You have to remember this word Orlon or acrylon. This is a substitute for wool making commercial fibers. Next one, acrylic fiber have good resistance to stain, chemicals, insects and fungi. Nowadays you maybe know that acrylic windows or doors are used because they are somewhat better quality to resistance to stain, chemical, insects and fungi. Okay, thank you very much.